Grade 12 learners, welcome to the Science Less channel. I see you are engaging and are active in my channel today. Thank you for those who liked, commented, and subscribed. I also see some of you are asking if this question paper is the one you are going to write on Friday. The answer is no. There is no one who has the question paper that you're going to write on Friday. I am here to assist you to revise and to learn the skills of answering these questions. All these questions are exam level and they'll assist you to be able to manage and handle your exam on Friday. We are moving along to question 9. This is almost the last question of your question paper. Question 9 is based on electricity and magnetism. This one focuses on electrodynamics, basically looking at magnetism. Now, this is the easiest chapter or topic you'll ever do in grade 12. Even when I was doing this question, I didn't have a lot to ask here. But just for purposes of revising, we'll go through it. So the question reads as follows. 9.1. They say the motor effect is the term used when a current carrying conductor experiences a force in the presence of a magnetic field. Obviously, we know that here we have an energy source or a power source that is generating electricity, and this electricity is there's a flow of charge in the conductor going towards the two magnets, right? That have the south and the north pole, and as a result, this magnet will then create or exert a magnetic force, right? Because there's a magnetic field causing that wire or the coil to turn, right? That's basically the dynamics or what happens in a motor, right? Now, what I've done here basically is just interpreting the problem, right? Looking at the understanding of a motor and interpreting the problem. Now, the first question, 9.1.1, says state the energy conversion that takes place in a motor. This means, for the fact that I saw that it's a motor, it means that I'm classifying the problem and now I'm going to answer the questions. The C stands for classification, A stands for answering the question. Now, in this question, 9.1, already when I was describing what is happening in a motor, you can see that we're taking electrical energy that comes from the power source and we're taking it into a mechanical energy because there's movement of the coil when we put our coil in a magnetic field, right? When we put the conductor in the magnetic field, it will experience the magnetic field which will cause it to start moving, right? Thereby giving us a mechanical energy. So the energy conversion that happens is electrical energy to mechanical energy. Now, under 9.1.2, they say, how is a generator different from a motor, right? Now, a generator does exactly the opposite of what a motor does, right? A generator converts mechanical energy to electrical energy. So in a generator, we put our conductor within a magnetic field. So we take two magnets that has the south and the north pole, right? We know that they're going to create a magnetic field and a magnetic force. Then we put a conductor in there so that it moves, and as it moves, the currents start existing in the conductor, right? So this means that a generator converts mechanical energy to electrical energy. right? Then we jump to 9.2. 9.2 says here an electrical appliance runs on a 220 volts AC alternating current and has a resistance of 150 ohm, right? So what do we have here? We have an electrical appliance. I'm going to write my data down here. So this electrical appliance has it runs on a 220 volt alternating current. This means that our voltage here is the RMS, right? So this is 20 volts, right? And the resistance here is 150 ohm, the resistance that we have in our appliance, right? Now the question says now calculate the actual maximum voltage supply. So what is the maximum voltage supply that we can give to this appliance, right? So we're going to use the formula that defines VRMS, because I can see that I have the maximum voltage there, which is what I'm going to look for or calculate. So when I substitute in here, I have 220 for the VRMS, and I'm looking for Vmax. So this is going to be that. Now here, when you cross multiply, you should be able to get Vmax of you're going to say here this multiplied by that, right? Because you're going to cross multiply. So this should give you 331.13 volts when you press that on your calculator, right? The next question says calculate the peak current in the resistor, right? The peak current. Peak means maximum, right? When someone says to you a quantity is at its peak, it means we're looking for the maximum. So this means we're going to look for the maximum current. And obviously the maximum current, if you go to the formula sheet, you know there's a number of these formulas. You know that these formulas, there's a lot of them there. You just have to check what you are given to see which formula to use, which one is best to solve a problem. So Imax is going to be Vmax all over the resistance, right? This one gives you the max current, but we know our max voltage. We just calculated that from the previous question. This is 331.13 divided by our resistance is 150. Just to double check that, yes, our resistance is 150. Now you can use your calculator here to say 331.13 divided by 150, right? This gives me a current, the maximum current that can be supplied to be 2.21 amperes. Now, the last question says here, calculate the root mean square of the current, right? So we're looking for the root mean square, right? So this is the RMS, right? Now when we go to our formula sheet, the formula that defines RMS is equals to Imax all over the root 2, and we know our Imax, right? So we just calculated Imax to be 2.21 all over the root 2, and punching this in the calculator would then give us 2.21 divided by the root of 2, and this gives us a current of 1.56 amperes. This is as simple as that. Now the only thing that we can do now is to actually then come to the last part of our problem solving strategy here and do the N, right? So remember, we interpreted the problem as we're solving it, and then we classify it to see which part of the topics does it fall in, which chapter does it fall in, what type of formulas do we have to use, right? And then we answered the questions really through calculations or giving explanations. Now when we do calculations, we have to navigate our answer. The N stands for navigation of the answer. So in this case, what we do is that we check if our answer makes sense, right? So I'm going to run quickly through these two answers that we have here. So if you check the maximum velocity, right, we expect this value to be bigger than, right, the VRMS, right, because this is an average. Remember, VRMS is an average of the peaks that we have on our sine graph, right? But this is the maximum that you can get to, right? So this answer looks great, and they're not that far. You can see that an average, is 220, and the maximum can go up to 300. The same is true with our current. If you check, the maximum current is actually bigger than our average, right? Right, our average is 1.65, right? So that's how we know that this answer makes sense, right? The other way in which you can navigate this is to change parameters in these equations and see how this will change. Maybe you increase the maximum and look at how this answer will increase, or you can decrease the maximum and check if this will decrease. So this speaks to the direct proportion. I mean, you can see that RMS is directly proportional to V to I max, right? And the same technique will apply here and see how the final answer changes, right? So this was sweet and simple.